Countdown.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Zan?
Okay, so Bismillahirrahmanirrahim. Assalamualaikum and salam sejahtera. Good evening and hi to all the students, teachers, parents. Okay, welcome to Pusat Tuisyen Academy YouTuber, a joint venture with e-didik Malaysia and Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah. And for the non-Muslims, please recite your prayers according to your religion. So how is everyone today? My prayer is that everyone is in the best of health and ready to start today's class. But first, let me introduce myself. I'm Cikgu Zanaria, aka Cikgu Zana, as your moderator for today. And together with me in the Conti, we have Teacher Im, our host controller, and our presenters, Teacher Ailin and Teacher Ailin from SMK Datuk Pengawal Timur, Pasir Gudang, Johor, and also Puan Ong Lee Ge from SMJK Chun Ling, Batuwet, Pulau Pinang. So let us give a warm welcome to our presenters. For the record, we are now live on Teacher Ailin's channel. So as a sign of support to Teacher Ailin and Teacher Ong for their hard work in preparing today's lesson, please subscribe their channels, okay, and not forgetting the teachers here too. Okay, as usual, the lesson will last approximately for 1 hour and the certificate link will be given at the end of this session. So be sure to follow the class up until the end and give your full cooperation in making this session a lively one. I would also like to remind students to use appropriate language and also use appropriate profile picture, if possible your own picture if you wish to post comments in the chat box. Okay, I'm sure all the students here are excellent students who will uphold a positive classroom environment. Those students, stay focused, and if you have any questions, please write on the chat box and Teacher Ailin and Teacher Ong will try to provide you with the answers. So without further ado, please welcome Teacher Ailin.
Hello. So guys, today we meet again here. So today's, since now it is already your SEM 2 exam, it is already coming soon. So today we will doing the ulangan, okay, ulang kaji for SEM 2. So if you are SEM 1 also you can join, you can ask your SEM 1 students to join to have the preview for your SEM 2 content. So if you are taking your friends are taking the ulangan for SEM 2, please invite them to join. Let us help you to do a little bit revision to recall back because your exam is coming soon. So hopefully we can a bit help you to do the revision. All right. So before this, so let me see. Okay. since you're doing the revision, so sure you need a lot of you need to refer to books or videos maybe. So here we have the playlist for all the videos for mathematics. This playlist is special for all the mathematics video. So this is the link. So you can go to the link and watch all the videos to help you to do the revision. Okay, then here we also have physics playlist. All the videos for physics also here to help you to do the revision for those who are taking the physics. Okay, you can follow the link here to watch the video. Then chemistry, this is the theme for chemistry. So same thing, chemistry. So same thing, chemistry will have their own playlist here. Inside this playlist, there are a lot of chemistry videos. So you can go and watch all the videos there. All right, this is the accountant and economy. This is the theme for accountant, matriculasi, and economy. Same thing, they'll have a lot of videos there. So please, this will help you to do revision. All right. So for now, today, to start the revision, I will do the topic for Maclaurin series. So because Maclaurin series is very important topic, this topic is very popular in section B also. All right. So when you want to do revision, so let's say for this Maclaurin series, so if you want to do revision, you must revise back everything all the teachers teach you. Okay, revise back. Okay, when we look at the chapter for Maclaurin series, okay, all together we divide into two parts. One part is finding Maclaurin series. Another part is application of Maclaurin series. Okay, for finding Maclaurin series, we have two, either using theorem, Maclaurin's theorem to find the series, or using standard Maclaurin series to find. Then as for the application, we make use of the Maclaurin series to find limit, or to find the approximation, or to deduce. When you are given a Maclaurin series, deduce a new series of Maclaurin series. Okay, so these are the what you learn in this chapter Maclaurin series. Okay, so now first I will start from the finding Maclaurin series. So today we have a very special guest. I invite a very special guest. She is Jeku Ong. Why I invite her? Because she is a very experienced teacher of teaching mathematics. She is from Chongling, Butterworth. So very experienced. So that's why I invite her to help me to do this revision about this part, finding the Maclaurin series. So stay tuned. So class, so we can gain something very important from our Cikgu Ong. Okay. So dipersilakan Puan Ong.
Hi everybody, very good afternoon. So thank you, Teacher Ailin, give me opportunity to have a space to share everything to everybody. Then I'm Ong from Chongling Butterworth. Just now Teacher Ailin already told that everybody. Then I teaching almost 20 years for Maths T, but
She's lagging. I think Puan Ong is lagging. Puan Ong, line dia tak kuat.
Coming.
So I think Puan Ong's line is not very good. So we try. Oh,
Okay. She's back. Puan Ong is back. Puan Ong, are you okay? Okay.
Are you okay, Puan Ong?
I still in screen, but
okay, yeah, all right.
Okay. So now I click just now is the internet is not stable.
Okay.
So I click the share already enough, or just click the.
Just
Click the slideshow. You can click the
Slideshow.
slideshow.
At the
Yeah,
bottom.
just teach like normal.
Click my slideshow.
Okay, be patient, students. Okay, because of the technical.
Okay, can see already.
Okay.
Yeah, can see, can
Yes.
see.
Can, huh?
Very good.
We are.
Okay.
Yeah,
Good.
good. We are your eyes.
Okay. So just now I said I already teaching for Maxi for 20 years until this coming May. Already totally 20 years. But I also learn from the others. So I would like to share what I know. So today I will continue to share about the question with the Maclaurin theorem and also the standard Maclaurin series.
Okay.
Okay, this is my first slide. Okay, that will be the Maclaurin theorem, that formula. So because today is our revision question, so I no need to tell you how to get this formula, you just use it only. So and then about the standard Maclaurin series, that will be this.
Next cursor.
Uh,
What on the next cursor?
no, I
Number
know.
3.
Number 3, yeah.
Icon number 3. Okay, that's right. Okay, press.
This one.
Yeah.
Now my screen becomes small. How do I go back to big screen?
Sorry, play. Okay.
Can now we all of you
Okay.
can see the whole screen. Can?
Yeah.
Yeah.
Yes. We can all
Yes,
see
yes.
the screen. You just
Don't
teach
worry.
like normal.
Normal.
Yeah.
Okay.
Don't worry. We are
It's
your
like
eyes.
normal.
So now I will continue to look through the example question 1. Now the question 1 is given that y equal to 1 over 1 plus sine 2x. State the value of dy dx and d2y dx square when x equal to 0, and then obtain the first 3 non-zero terms in the Maclaurin series for y. Now when the question given you the y equation in terms of x, and then ask you to find out or show the equation dy dx or d2y, means that we are already using the differentiation to use the Maclaurin theorem to find the answer. So now look at the answer, how we do it. So look at the question given, y equal to 1 over 1 plus sine 2x. Now we have two rules. The first one is product rules, the second one is quotient rules. Some students they like to using the quotient rule, but when they using the quotient rule, the numerator they were using the plus something. The first term plus with the second term, they always mix up the product rules and quotient rules. So I prefer teach them using only product rules. So that's why the first line, I asked them, I asked students like to change this rational function become a multiplication function. So become 1 plus sine 2x times y equal to 1. Then later on from this first row, then I using the product rule to find the answer. And then continue here. The product rules here, you will remain the first term, that's 1 plus 2x. Then later on, different the y, dy dx. And then here plus, then remain the second term, that is y. Then different the 1 plus sine 2x. Then different constant, you will get 0. Then different sine 2x, you will get 2 cos 2x. Okay? Then later on, different constant, you get 0. So if you know how to difference first time, the first derivative, then you get the first and 1. Then from the student result answer, mostly they cannot cope very well the product rules or quotient rules. So mostly the second derivative they will did wrong. So I hope the student can do the revision, make sure that you can do the differentiation correctly. And then look through the third row. We are going to do the differentiation second derivative. Then here have two terms. Two terms all must using the product rules. So this will be for the first term, we make the 1 plus sine 2x, then different dy dx, become d2y dx squared. And then plus with, we make the dy dx, then different the 1 plus sine 2x. So this is for using the first time, the product rule for first term. And then here will be the product rule for second terms. So look at here, I will remain 2y, then different cos 2x. So different cos 2x, you will get negative sine 2x. And then plus with, you remain the cos 2x, then different 2y. So you will get 2 dy dx here. So I will arrange the factor. Then if the question asks you to find the values for d2y dx squared when x equal to 0. If you don't want to simplify the same term for dy dx in only one term, you can leave here. So your marks for answer will be get here if you all correct. If here have two terms, if you want one product will be correct, then the other one correct, then you will get N1A not already. So this is how. If a question didn't ask you to show that this one, so this the fourth row, you don't need to write down, never mind. Okay. So now next. So how to calculate the value for dy dx and d2y dx squared when x equal to 0. Now you look at here. I didn't do the calculation because of for the marks here, mostly they all given all marks are only 1 marks. So the best way is you can using your calculator to calculate the value. Substitute all the x equal to 0 and following by, you get here x equal to 0, you get y equal to 1. You write down. Then later on for the second row, you substitute your x equal to 0 and y equal to 1 to get your dy dx value. By using your calculator, then you get your answer here. You can write here. And also the same technique. You substitute the x value equal to 0, y equal to 1, and then d2y dx equal to negative 2, then you can get your d2y dx value, square value. Then this value mostly you write 3 or 4, must sometimes until x power 4 you have 5, then you only get 1 mark. So be careful the values here. If your differentiation for second derivative is wrong, then this answer you will get 0 marks here, because this mostly they all correct, then they are given only 1 mark. Okay, then later on the question say obtain the first 3 non-zero terms of the Maclaurin series for y. Then we using the formula for Maclaurin theorem, substitute the value y, dy dx and d2y dx straight into the formula. Now here no need to write down the formula, you just use the formula, substitute the value you get. Now this n marks if your values at here is wrong, but you know how to using your answer to substitute into the formula, the n mark you still can gain, but only the last answer a mark you cannot gain. So be careful here. Okay. So sometimes students they think the value he wrote here is, let's say it's negative 8, but he put here is 8, then he used a wrong answer, then no mark already. If here is your answer is negative is wrong, but you put here is negative 8, then we said you're using his answer, then you can gain the marks for this n. So this is how we do the question 1. Okay, now go to question 2. There's another question for also using the Maclaurin theorem. Now, just now the question 1 is using dy dx and d2y dx squared. But this question using the y prime and y second prime. Sometimes they also using that like this. So for example, this question given that y equal to ln 1 plus sine x, show that y second prime plus y prime all square equal to equal minus 1. Here the question given is 3 marks. And then question say hence. Now then use a Maclaurin theorem to find the Maclaurin series for the y in as any power of x up to the x power 3. Now before I start to explain how to do this question, I would like to explain first. Now the question given you show and also the word hence. Now this word hence very important. Some students they didn't use and they maybe using the second row for the derivative to find the following. They didn't using the show equation to find the following. Then although they get the answer all correct, but the following 6 marks will gone. So be careful the word hence. Very important. They will mark like that. Then later on we look through the answer how to do this question. So question 2 is y equal to ln 1 plus sin x. Now here the formula y, when you do the first derivative, it will become a rational function. So mostly I also don't like to using that formula. I would like to change it to become NP-ln, become exponent
Exponential.
function. Because different exponent function will go back to exponent. It's easier. And then they didn't have a rational function. So here I change to exponent first, become e power y plus equal to 1 plus y. Go back to the same, then different the y become y prime. Now because the question given asks you to show that it's y prime and y second prime, so I'm using this symbol. Okay, this symbol is same like dy dx. Then later your right hand side is 1 plus sin x, this become cos x. Then if you can do this, then you can get the first one with the method marks, that's n1. Then later on the second derivative, so this time again differentiate the second row with respect to x, then you get this answer. So here again be using the product rules. So I remain the e power y, then different the y prime, so you get to y second prime, and then plus remain the, then you differentiate the e power y, you will get this one. So multiply this y prime, so it becomes e power y prime all square. Then your right hand side is cos x. Even cos will get negative sign. But you look at the equation asked you to show is without the symbol logarithm and trigo. So you need to change this trigo sin x. So from the second row, I already empty ln, change to exponent y become 1 plus sin x. So you will change the sin x become e power y minus 1. And then in front here negative x, negative 1. So your term will change to 1 minus e power y. And then the question required the equation shown in this question, so we try to rearrange become this. But when you check here, every term has e power y, so you need to divide every term by e power y. Then later on, you will get the same equation like the question required you to show. Same, then we show the answer. Now, sometimes the student they were cheating. They would like to copy this equation given by question, then they said shown. But when the students so do that, we need to check whether they do the approach, whether it's correct or not. If here is wrong, then the following answer A1 is not given also. So the method marks here, the second method marks is very important. We must check. And then continue said, just now I said the question say hence. So say hence you must using the previous equation to do the differentiation until x power 4. So you must using this shown equation to continue doing the third derivative and also fourth derivative. So the technique is still the same. The left hand side, y second derivative different with respect to f change become y power 3. Third derivative. And then the second term is y prime square. So when you do the differentiation with respect to x, we are do the explicit differentiation. So we firstly do lower the power of 2 first, then later on different the y prime, it become y second derivative. Then this one e power negative y same like just now, but here have a negative. So when you differentiate, you go back to e power negative y first, then different negative y, you get negative y prime. And then different constant, you get a 0. So no need to write down. And then after that, continue do the fourth derivative again using the product rules. So you will get here third derivative we are different with respect to x become y power 4. Then here using the product rules. Okay, and then here again right hand side also using the product rule. So I prefer using product rule. Here always plus. Okay, so then everything you can do it, then you can get M1, then all correct. both sides correct, then you can get A1. Now this M stand for, here you using twice of the product rules. So mostly we said that either one correct, then you already can given M1 because you already try to find out the following differentiation. Then after that, we are going to find out the Maclaurin series. So we need to substitute the x equal to 0 to the y equation, dy dx equation until at the power d4y, the x power 4 equation. So try to substitute it, then to using a calculator to calculate the value. Then write down all the values here. So here you have 5 values. So only have 5 values, then you only can gain 1 marks. If one of them is wrong, then here B not already. Sometimes they given B, sometimes they given A mark. It depends too. Then later on, you using this mark, then using the scoring formula, then you substitute into the scoring formula with your answer you get in this row. Then simplify your answer. Then your answer already in terms of until x power 4. Okay. Then this will be question 2. Then next we go to question 3. Now question 3, this question is using the clone of the SVM question. I change the question is y equal to e power arctangent 1 over x. Then show that the equation is 4 plus x squared dy dx squared plus 2x minus 2 dy dx equal to 0. Then later on, hence, again, here the word hence, find the Maclaurin series for y in ascending power of x up to the x power 3. So the first step is ask you to show this. So the solution is, now y equal to e power arctangent 1 over 2x. Now if you want to using direct this equation to find the dy dx also can, but because of here power and also the power is the arctangent, so quite difficult. So I would like to change this become ln. Become ln here. Ln here, then you have a power, easy for you to do the differentiation. So for different the ln, here I'm using just now question 2 have a ln. Differentiation for ln is become a rational value. So because of here y only have one term, so never mind, we can using the rational value also still easy. So I different the ln y, you get 1 over y. And then if different the y, you get multiplied with dy dx. And then this different the arctangent, it be a rational value. So quite difficult. So here will be 1 over 1 plus the 1 over x all square. Then later on you different 1 over 2x. Then here multiply with 1 over 2. Then this will differentiation for arctangent 1 over 2x. And then here I would like to tell you, now we learn the arctangent for arctangent, arcsine, arccos also. But the formula given here all is x. But during the STPM exam, they would like to test you here is maybe it's 3x, 2x, or rational value. They won't test you the only standard formula. They will test you the more complicated version. So here maybe it's 1 over 2x. Here maybe it's 2x or maybe 3x. You can refer to the past question. It comes out with 3x. So be careful. So when come out 3x, mostly students will forget. Even the 3x here must have a constant 3, but they all always missing this value. So be careful. So then later on, because this equation is a rational function, so quite difficult. So I would like to using cross multiply actually become into a product. So before I change to a product of two functions, the denominator for right hand side change to one rational function. That is 4 plus x squared divided by 4. And then the denominator for the this function multiplied with 1 over 2, then become 2 here. And then the denominator 4 plus x squared multiplied with dy dx, then become this term. And then this y cross multiplied with to the right hand side, then become y here. Then become the pattern, similar like the question, the equation we're going to show. Okay, then but because of the equation asked us to show is a second derivative equation, so we try to do the differentiation for this equation. Second time. Then the left hand side again we using the product rules. Okay, the product rules. So we mean the first term different the dy dx, and then plus we mean dy dx, then different 4 plus x squared, then you get 2x. Then your right hand side is 2y, you different 2y, then you get 2 dy dx. Then, but the question asking to show only have one term of dy dx. So we try to factor the dy dx to be a common factor. Now, although here 2 is also is a common factor, but the question requires us to show that it's 2x minus 2 dy dx. So the 2 don't factor right out. So leave it the same like the question required. Okay, don't simply change. Okay, must follow the question instruction. Okay, then next. So the question asks, hence, find the Maclaurin series for y in ascending power of x up to the term x power 3. So the words again come up hence. So be careful. We must using the show equation to do the differentiation until x power 3. So this will be your answer. Okay, so from this equation, you have 2 terms on the left hand side. Then we must using 2 times of a product rule to do the differentiate. The shown equation become this equation. Okay, then later on, now because of the question didn't ask you to show that this the second row equation, if you don't want to show to simplify the 2 term of the 2y dx squared become 1 term also, never mind, you can leave it from here. Then later on you substitute your x equal to 0, then to find out the y value, dy dx value, the 2y dx value, until the 3y dx power 3 values. Okay, after that, you use again the Maclaurin theorem formula, substitute the value you get here, this one, into the Maclaurin theorem formula, then you simplify the coefficient for x and x squared and x power 3, and then become this. This will be a series until ascending power of x up to x power 3. Okay.
All right. I think point on is we can take a break now for the advertisement. It's time for advertisement. Okay.
Okay, thank you.
Semua sekolah ditutup hingga cuti akhir tahun 17 Disember 2020. Anda tak cukup bahan? Tak ada rujukan? Tak faham? Anda nak tuition tapi PKP? Jangan risau, kami di Akademi YouTuber dengan kerjasama Kelab Guru Malaysia dan e-Didik Malaysia mengadakan kelas tuition online. Semua peringkat ada, semuanya secara percuma. Video PDPC pun ada. Apa ditunggu lagi? Layari www.academyyoutuber.com. Dibawakan kepada anda oleh Akademi YouTuber.
Okay, shall we continue with point on?
Okay, now I continue with question 4. Okay, this will be a question 4. Question 4 is find the Maclaurin series of fx equal to x e power negative x minus sine 2x over x up to the term in x power 3 is find out. Can you compare the question 1, 2, 3 with question 4 if any difference? So question 4 only said find the Maclaurin series. Didn't show any dy dx and d2y dx square equation. So this is means that this type of question we can direct using the standard Maclaurin series to find the answer.
Okay. There's a question by one of the student. Does formula Maclaurin series given in the exam paper?
Yes, they given in the paper.
So it's answer, Muhammad Syafiq. Okay, continue.
Okay, can I continue?
Yes, you may.
Okay. Now for this question 4, fx is a rational function, but do you notice here the denominator only have one term? If you want to simplify first, then substitute using the standard Maclaurin series, you can do like that, like the question I shown is here. Or if you don't want to simplify first, then you just substitute using the e power x and sine 2x Maclaurin series formula to substitute also can. At last you will get the same answer. So here I simplify first. On the first term become e power negative x. Then the second term become negative 1 over x times sine 2x. Then later on, the e power negative x, this term, I will using the standard Maclaurin series formula for e power x. All the x change to negative x. Now question required is until the term x power 3. So I only substitute the term until x power 3 only. Then the rest I no need to write down. And then for sine 2x also the same. Using the sine x formula, change the x formula in the formula become 2x. And then the question also is until x power 3, so I only substitute until the second term only. Then the rest I using plus dot dot dot. Okay, then later on, after you substitute all the term into using the Maclaurin series formula, then you need to simplify. Simplify all the coefficients. Okay, after that, after you simplify, here have a marks, m1 marks. Then later on, you look through all these series. If they have the same coefficient for x squared, then we need to combine. We arrange from ascending power until x power 3. Then this will be our answer. Okay, so you get the A1 and the last one A1 answer. So here have 5 marks. Okay, next question 5.
But before that, teacher Ailin, when are you going to take over after this? Teacher Ailin, Mike.
Question 5, teacher, can I continue?
Yes, you may.
Okay, so question 5 is use a Maclaurin series to show that y equal to ln in bracket 1 minus sin x in ascending power of x up to the term x power 3 is. The question asks you to show that, means that if you're using the Maclaurin series, you already have a guideline to get this answer. Okay, then later on, the question again says hence reduce ln 1 minus x sin x alpha power negative 2. So this is a bit is application. Never mind, I continue the question because mostly the Maclaurin question, they not only ask you to do the Maclaurin series, they will add something. So how about this solve this question? Okay, the question is y equal to ln in bracket 1 minus sin x. Now, same like question 4, this question didn't ask you to show that the second derivative or dy dx equation in terms of what, but so it means that we are going to using the Maclaurin series formula to find the answer. So refer to the y equal to ln in bracket 1 minus sin x. You compare to the Maclaurin formula, that is y equal to ln in bracket 1 plus x. So you compare with this, then the formula y equal to ln 1 plus x, all the x place change to negative sin x. So you will get this second row. Now question required to show that your ascending power of x up to x power 3, power 4. So I need to sub your sin x until x power 4. Why? You look at the drawing as I explained to you. Now here, after that, after using the standard series, then we try to simplify first before we continue to substitute using the sin x Maclaurin series formula. So I simplify first, then the coefficient for every term becomes negative. Then later on, we using the sin x Maclaurin series formula. Now question require until x power 4. So I'm only using until the second term for Maclaurin series for sin x until x power 3 only. Okay, already enough. Then the first term you multiply with negative 1, then you get these two terms. Simplify the coefficient 2. Then the second term is x minus x power 3 or factorial plus the power 2. Then here after the power 2, here have two terms. If you expand, you have a 3 term. The first term is x squared. The second term will be the term in x power 4. Then the following term will be x power 6. Then the term for x power 6 already more than x power 4, so we leave it just using the term is plus dot dot dot. So I will only write down these two terms. Then for the third term, x minus x power 3 over factorial 3 plus dot 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 power 3. If the power 3 here have two terms, then you expand, you must have 4 terms. the first term is x power 3. Then the second term will be x power 5. Then I'm following all the terms at behind all more than power 4. So we only using the first term. That's why here you get negative 1 or 2 x power 3. Okay, and then the last term, x minus x power 3 over factorial plus the power 4. If only consider 2 term power 4, when you expand, you have 5 terms. So the only first term you can use, then the rest all more than power 4. Okay, then I put the plus dot. Then later on, try to expand, simplify the same, in only ascending power of x. Okay, before I continue to do the hands, here I would like to explain a bit. Do you notice for the series, when we write the series with ascending power of x, we must write down the plus dot. Okay, but at last for this answer, I didn't write down the plus dot, but I changed the symbol. The equation symbol I changed to approximation equation equal symbol. Okay, so this is also the same. Now, when you're using the Maclaurin series or Maclaurin theorem to show that your answer, you must at least write down one times of the plus dot. If whole question you didn't write down plus 1 dot, then your answer is correct. Then we will minus 1. So be careful. So you either can write down plus dot, or you can write down using the symbol approximation equal symbol. Okay, this is the technique we will answer the question. Okay, then I continue. Next, hence, how do we going to solve the last part? Deduce the ln 1 minus sin x power negative 2. So here will be your question. Using the property of logarithm, here minus 2, then we put it inside in front here. Then the ln 1 minus sin x is already shown in this part. Then we just copy, then expand, then your answer. Okay. Then the last example. So expand ln 1 plus x sin x up to the x power 4. Now this question is a bit similar like just now. So it's same also. No, didn't say anything. So we just using the formula. Change the x sin x into the formula place. All the x are the ln formula. All the x place change to x sin x. Then later on you try to expand. Then you get the answer. So it's the same skill with before question. So that's all. Okay. Any question that they can ask. Thank you very much. Okay, thank you. So I pass back to teacher Cikgu Jana. Thank you very much.
I think Teacher Ailin turns to do the presentation. Teacher Ailin. Teacher Ailin, we can't hear you.
Okay. Sorry.
Okay.
Now I go to my part. My part is about application, the Maclaurin series. So I'll go very fast. So the first one, So the first one, doing limit. So for example, using the Maclaurin series, cos 2, find the fourth term, then hence. Normally, application of the Maclaurin series is after you're asked to find the Maclaurin series. So this part, since Cikgu Ong has already explained very detailed, then I no need to go through again. So you just apply the standard Maclaurin series x, the original x, you substitute with 2x in order to get the Maclaurin series first. Then after that, okay, now first you find the Maclaurin series for sine squared x first. Then after that, straight away apply at the limit. So when you want to do limit, straight away you substitute the Maclaurin series that you have got just now. So you substitute into here. Don't forget about the dot, even though you substitute here. So then after that, you simplify first, because x power 2, you can add minus x power 2 to get rid of the x power 2. But here you cannot straight away substitute the value of x. If you substitute the value of x, you find that on top is 0, below is 0. So now you notice that you can still simplify the x. That is, you factorize the x power 4. So when you factorize the x power 4, you find that x power 4 can be cancelled off. So once you cancel off the x power 4, now again you substitute the 0 into here. So now since this one is 0, so all the term after that has got x. So since x is equal to 0, so all the term after that is equal to 0. So when you simplify, then you will get the limit. So if we want to use Maclaurin series to find limit, normally is x approach 0. Okay, x approach 0, then we can use Maclaurin series, because Maclaurin series is generated for the approximate value of x equal to 0. All right. So this is one of the application of Maclaurin series. The second application is we use the Maclaurin series to do the approximation of this definite integral. So for example, use standard Maclaurin series to find the Maclaurin theorem. Okay, for this one first. So same thing. We are going to apply the standard Maclaurin series. The only thing is you substitute the x square root with x. So then after that you simplify. So when you simplify, you find that, okay, you can do the integration already. So for the, if we want to use Maclaurin series to find the approximation of this integration, normally this one fx is difficult to integrate. Okay, so if fx is easy to integrate, we don't have to use Maclaurin's theorem to help you to find the approximation. So normally the cos is difficult to integrate, then we make use of the Maclaurin series to help us to find the approximation. So the value that you get from this Maclaurin series, that is approximation. If you are able to integrate, the value that you get is exact value. So means we call it as approximation. So now we start to do the integration, each of the term like normal. Okay. Then remember, even though after you have done the integration, remember you must write the dot 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 also. If there is definite integration, you have the lower limit, upper limit, so you don't have to plus c. Okay. Then after that, you just substitute the 1 into the x, then minus, substitute the 0. So you can see that when we substitute 0, everything is equal to 0. So now when you simplify, your final answer, because this one is approximation, remember, this one must be using the approximation equation. That is the wavy and wavy equation. So you give your answer in 4 decimal places. All right. So this is the how you use the Maclaurin series to find the approximation of the definite integral. So other than definite integral, we can also use the Maclaurin series to find the approximation of a value. Okay, let's say the first part show the first 2 non-zero terms of Maclaurin's expansion of arc-sine. Okay, now you are asked to show this one. Okay, so now since Cikgu Ong has already explained very detailed, so I leave this part as your working, as your homework. So you go back home and try to show the arc-sine, the Maclaurin series, this one, by using the method that I have told just now. Now, hence, deduce an approximation of pi as a rational fraction in its lowest form. So hence means you are going to use the answer just now. That is arc-sine. Now, if the question asks you to use arc-sine to find the pi, sure there is something relationship between pi and arc-sine x here. So you can start from whatever you know. Normally, arc-sine students are not very familiar. Okay, let's say you start from sine. Okay, you list out all the value that possible for the value of sine can produce exact value, because you are asked to give your final answer in rational fraction in simplest form. Means your final answer should be in the exact form, not the decimal value. So so you list out all the possible value. So when you convert to arc-sine, let's say sine pi is equal to 0. So if you convert, becomes arc-sine 0 is pi. So sine pi over 2 is equal to 1. So means arc-sine 1 is equal to pi over 2. So when you list down here, so these are the red number here, the red color number here. That's are the possible value of x that you can choose to substitute into the Maclaurin series here, so that later you can find the value of pi. But the problem is which value is suitable. Now, okay, first, definitely we won't choose 0 because if 0, we substitute into here, so everything becomes 0. So 0 is out. Then after that, because the question said the final answer should be in rational fraction, so means definitely it is not cert 3. It is not cert 2. So this one, cert 3 and cert 2, these are out. Because if you press calculator, cert 3 you will get decimal number. Cert 2 you get decimal number. So but the question asks for rational fraction in its lower form, means your final answer is in exact form. So means 0 is out, this one is out, this one is out. So now the remainder, we either choose 1 over 2 or 1.
Yeah.
Okay, but you know that the value of x for arc sign, the domain is from -1 to 1. So if we choose x is equal to 1, it is at the boundary value, so not very suitable. So we choose the x is equal to 2 is suitable. Okay, so 1 over 2 compared with 1, 2 is approximate to 0. All right, near to 0. So that's why we choose x is equal to 1 over 2. So let x equals 1 over 2. So once you have decided you want to choose x equals 1 over 2, so now you just substitute x equals 1 over 2 into here. Okay, so since x sine 1 over 2 is pi over 6, now you see you can the pi is already appear. Then for this one, you just simplify by then you get the don't press the calculator to get the decimal because the question asks for fraction in lowest
Fraction.
form. Okay, so you leave your answer in fraction form. Okay, once you leave your answer in fraction form, since just now we have dot dot dot, so now you don't have the dot dot anymore. So now this symbol you have to give it to approximate value. Okay, then finally you shift the 6 to the on top. Now you get the approximation of pi as a rational fraction of in its lower form. So that is the answer. All right. So I have two more very fast. Okay. So now, okay. Example number 4, show that the Maclaurin series is this one. Okay, this one also the same thing. I leave this one as your homework. You go back home and try to show this one, it is equal to this one. Now, hence, normally the hence, you're asked to find the Maclaurin series first, then apply the Maclaurin series that you have. You apply this one, deduce the Maclaurin series for arctangent. So if you are asked to use this one to find arctangent, sure, there is something relationship between arctangent and 1 over 1 plus x power 2. All right, now, students, tell me, what is the relationship between arctangent and this one? Someone tell me? Can you?
Yes, anyone?
Anyone?
You can write in
What's
the
the
chat
relation?
box.
Yeah.
You can write in the
What's the
chat box.
relationship from 1 over 1 plus x power 2? How to get this one arctangent? Can someone tell me?
Okay, what must you do, student?
Differentiation? How
Huh?
about the rest?
Integrate.
From this one go here. It is not from this one go here because we start from whatever you have.
Okay, there's answer there, teacher
Yeah.
Ailin.
Yeah, I
Shafiq,
can see.
Okay.
You use integrate, kai chin.
Yeah, Kaichin.
Yeah. So we look at the agenda. You give me integrate. Okay. If differentiate, it is this one. If integrate, it is this one. Okay. We should start from whatever we have. Whatever if we have. So we have is 1 over 1 plus x squared. So we should use integration. It is not differentiation. All right. So we should use integration. So the answer you will get arctangent like this. So means you need to do integration. So start from here. So therefore you need to integrate. So both sides, if you integrate, you need to integrate left hand side and right hand side also. So on the left hand side, so from the formula, it is arctangent. Okay, on the left hand side, you don't have to write C. C we write on the right hand side enough. One time we write C already. Okay, then on the right hand side, then each of the term you do the integration. include the dot dot dot. Remember, even though you have dot dot dot, remember after integration, if you don't have the number here, you must put the C. You must put the C. Okay, if not, it's considered as wrong. Okay, then after that, your problem is you have to determine what is the value of C. Okay, to determine what's the value of C, you assume x is equal to 0. Why x is equal to 0? Why I cannot choose what x is 1? Because Maclaurin series is the series that you generated when you do the Maclaurin theorem. You substitute x is equal to 0 to find the y, to find the dy dx, to find the d2y dx squared, that one, what, yes or not? So Maclaurin series is the series that you generated approximate to x equals to 0. That's why we choose x equals 0. We cannot choose other value. So when x equals to 0, so we substitute x into here, then c is equal to 0. This part you must show. Okay? Then finally, then you therefore you get the series of Maclaurin series for arctangent is this one, since C is equal to 0. All right, so this part you have to show. So this is how we apply the Maclaurin series to generate the new series. Okay, the last one. Okay, using the standard Maclaurin series to show that this one is equal to this one. Same thing, this one just now Puan Ong has already explained in detail, so I leave this one as your homework. So now, hence, deduce the series expansion of x cos x squared. Same as just now. If you are asked this one, you are asked to use this one to deduce this one. Sure, there is something relationship between these two. Okay, now tell me, what is the relation between this one and this one? Can you tell me?
Okay,
How to start from here? It is not start from here. Start from whatever you have. From sine x power 2, how to get x cos x power 2? Can someone tell me?
Okay, students, what do you need to do?
What you need to do to start from sine x squared to get
Right.
x cos x power
That's
2?
fine. Yeah.
How? What you should do? What you should do? Is it integration?
Because it's x.
Is it differentiation?
From sine x squared becomes x cosine x squared.
So
Okay,
sine
good.
x squared becomes x cos x
X
squared.
squared. Okay, x
So
guy there.
I can see JC give me differentiation, x guy differentiation. Kai Chin, is that integration?
Integration. Inter.
Jengta, differentiate. Okay.
Okay,
Now,
then divide by 2.
you should do differentiation. Okay, we have the formula of differentiation. If you want to differentiate, sine becomes cos. Okay, in this case, fx is x power 2. Then after that, you need to differentiate this one, x power 2. So when you differentiate x power 2, you'll get 2x, right? So means if you differentiate this one, okay, you need to do differentiate on the left-hand side and also on the right-hand side, both sides. Okay, so when you differentiate, you see, first sine, you change to cos. Okay, then the x power 2, you copy down. Then after that, you need to differentiate x power 2. When you differentiate x power 2, you will get 2x. So you get 2x cos x power 2. Then on the right hand side, also the same thing. You do the differentiation. X power 2, you get this one. This one differentiate, you get this one. Then one by one, you differentiate. Remember, you should be the dot 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 behind, even you do the differentiation. All right, so now we want x cos x power 2. Okay, so means the 2 here, you need to shift to the right hand side. Okay, shift the 2 to the right hand side. Becomes divided by 2, divided by 2. So every term you divide by 2. All right, so when you divide by 2, you simplify, then that is your series expansion for x cos x power 2. So is that okay? So I hope this one can help you to recall back everything that you have already learned in term 2. Okay, So I think it's already time. Yes.
Okay. Okay. Right. With God's grace, we have reached the end of this lesson. And today I find that the lesson is very, very comprehensive and very beneficial to all the students here, especially Puan Ong and Teacher Ailin has given you so many answering techniques, okay? And the favorite word for today is hands. Don't forget hands. What does it
Yeah.
mean by hands?
You have to be very careful about the word hands.
And then the symbol, the approximate symbol, okay?
Yeah,
So I've
and the
learned a lot.
dot. And
Yeah,
the
dot. Okay. So these are the few things that students must remember when doing Maclaurin series. Okay, it's a good lesson, and it's a refresher course for me too, because I have not done this for some time. Okay, so before we end our session, can you all please subscribe to Teacher Ailin's channel? Okay, and please subscribe. And if possible, you can subscribe to Teacher Ong's channel too. Find for her channel, okay? And don't forget to Teacher Im and Cikgu Zana's channel. Please subscribe us to show your support to us, okay? And hopefully it will motivate us to do more videos. Okay, right. Next, please, the link is already given. Okay, the link is already given in the chat box. Okay, please take note, the link will end half an hour after this live. Make sure to use the EDD email only, okay? And incorrect email will not be entertained. So please, if you haven't got one, apply to EDD, okay? And apply to EDD. And also, if you want to have more information on the online classes, please go to www.academyyoutuber.com. And to those who haven't joined EDD Junior Telegram, please do so. There's so many information inside there, okay? And then before we end, would Teacher Im would like to give a few words to the students? Teacher Im, your mic.
Let me.
Okay.
All right. All right. Do you like what you see? Okay.
Yes.
We have a new teacher here, and next week we have another. We will invite more guests in, and this teacher will be sticking with us. So make sure you subscribe to them, and I hope to see all the wonderful teachers joining us. Okay?
Yes.
Hit the
Okay.
like button, hit the subscribe button. We are here, and that subscribe and like button is our power up mode. Every time we come back from work, we are very tired, and that when we look at the like button, we say we have to help these students, and that's why we are all here. Okay? Do hit the like button.
Okay, so once again, thank you to all the students for joining today. You are very awesome, and congratulations. So feel free to join all these free tuition classes to your friends and teachers all over Malaysia. Okay, remember, this is a collective effort from all the teachers throughout Malaysia for all of you students out there. So thank you too for being a YouTuber Academy supporter. So I think that's all for now. See you again in the next session. Ingat hashtag bermula percuma, selamanya percuma. Assalamualaikum. Stay safe till we meet again next week. Same day, same time, Saturday, 5 p.m. Bye-bye. Goodbye.
Tuition online percuma. Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuition online percuma mestilah Akademi YouTuber.
Dibawakan kepada anda oleh Akademi YouTuber.